Hello, today we are going to be practicing our coordinate geometry and we are going to be revising what we did with coordinate geometry in junior cycle. So we're going to start off by reading the coordinates of our points and then we're going to apply 3 of the formula that we used in coordinate geometry in junior cycle. Now from the very beginning we're training ourselves for the exams at the end of the year. So what we're looking at is page 18 in our log tables. So anytime we're doing coordinate geometry, that page comes out so that by the time we get to the exams, it's total muscle memory. We know where we're going. We know what tools we have available to us. Now, let's jump into it with looking at our coordinates. So anytime we want to read coordinates on our X and Y axis, we're over on the left-hand side of the page and we have A and B, and I want to know the coordinates of A and B. So the way that I read that is I'm going to always start at my origin, where the two axes cross each other, and then I'm going to go in the door and up the stairs. So I'm going to go in the door -2 and up the stairs 3. In the door -2, up the stairs 3. That's the coordinates for the point A. This is exactly the same way as we would read a map. So in the door 4, up the stairs 5 gives me the coordinates for B. So now I have my coordinates A and B. If I'm asked in the question to get the distance between A and B, what's my first job is going to be to write down what A is and what B is. I'm writing that down immediately where I am writing out my question, my answer. And I'm going to look at my formula on page 18 and I'm going to see the distance between 2 points is given by this formula here, and I'm going to write that down on the page. Then I see that I have x1s, x2s, y2s and y1s, so I'm going to write them down. So I'm going to pick A as my first point, so I'm going to call it x1, y1 for its coordinates, and B is going to be at x2, y2. So I've written down my points, I've written down the formula I'm going to sub into. A quick reminder on notation: I have A and B inside 2 vertical lines. That means the modulus, that means the absolute value, and in the context of coordinate geometry it means the distance between our 2 points. It's always going to be the magnitude of something, and in this case we're getting the magnitude of the distance between A and B. So now we are in a position where we have written down our points, written down x1, y1, x2, y2, we've written down our formula, and now we can sub in. But in every single question, these are our steps. We're going to write down the points, we're going to write down the formula, and then we're going to sub into the formula. And in that way, we guarantee all of our marks as we're going. If we skip steps, we risk losing marks, even for good work. So I'm going to sub in now. x2 is 4, minus x1 is minus 2. I'm careful that whenever I'm subbing in a negative number, I'm always going to put brackets around it. If you're concerned about that, put brackets around everything that you sub in. So we've subbed in now into our formula. When we tidy that up a little bit, we'll get 6 squared plus 2 squared. When we tidy that up further, we're going to get root 40. And we have to be able to, remembering back to our work in algebra, be able to break that down. So that 40 could be broken down into 4 by 10, and root 4 is 2, so that would be the same as 2 root 10. This is a distance. I'm not given the units I'm working with here, but because this is a distance, I'm going to write down units, and they're inconsistent from year to year as whether they dock you marks for this, but we don't want to be losing marks when we've done the hard work. So if you're dealing with a distance and they haven't given you units, you just write down units for the distance. A final reminder on the distance formula: where does it come from? It's just Pythagoras. It's just a hypotenuse of a right angle triangle, and our right angle triangle is going along and going up. And we're looking for the distance. We're looking for the hypotenuse of that right angle triangle. That's where the distance formula comes from, and we want to know that in the back of our minds in case they try to apply it in some way in an exam question. Next one, midpoint. So the midpoint is exactly what it sounds like. It is the point that is midway between 2 other points. And as you might expect, we are effectively going to get the average of the x's and the average of the y's. And there's brackets and a comma in here because the midpoint is a point. It gives us coordinates. So we don't want to drop these brackets and this comma. They're part of our answer. They are the coordinates of the point that is halfway between our two other points, A and B. And you can see as I'm writing here, I have capital M for midpoint and I have subscript AB to keep track of which midpoint I'm talking about, because in a higher level type question in the exams, there's likely to be more than one of these going on, and having our subscripts here will help us keep track of it. Again, I'm going to write down what A and B are. When I am doing my questions, I'm always going to write this down. There will be multiple points to deal with in an exam question, and if I have trained myself to always write down my points, I'm going to be vastly less likely to make a mistake in the final exam. So I've written down what A and B is, I've labelled them, and I'm now able to sub in. Open up my bracket and I'm getting the averages here. So the average of my x's, the average of my y's, and I end up with 2 over 2 and 8 over 2. I end up at 1, 4. Something we should always do in mathematics is go back to our picture if we can get one and see if it makes physical sense. So where is the point 1, 4? I start at the origin, I go in the door 1, up the stairs 4. And I can see that that makes visual sense. I can see that it makes sense that that is the point that is halfway between my 2 points A and B. So I'm happy that I haven't made a mistake because I've used my picture to check my maths, and that's going to be critical for being able to do lots of exam questions, to be able to link between what we're doing in the algebra with what we are going to draw in sketches and in pictures. Next, slope. So you have the concept of slope. Already we know that the concept of slope is rise over run. That's the first way that we deal with it, rise over run. And we do that pictorially. Change color. If I go between A and B, I'm going to rise by 1, 2. And I'm going to run across by 1, 2, 3, 4, 5, 6. So I know that my slope from my picture is going to be rises 2 over run of 6, which simplifies to a third. So from my picture, I already know exactly what the slope is going to be because I know how to use rise over run. The picture is critical to doing higher level maths. Now, we're going to use the formula as well because sometimes we will have to use the formula. The numbers will be too awkward, and we also need the concept of the slope for when we come to something called differentiation later on in the year. This is going to be critical for our understanding later on in the year. For a more advanced form of maths. Now, as always, write down what A and B are. Minus 2, 3. B is 4, 5. X1, Y1, X2, Y2. Sub in. Little m, subscript AB to keep track of which slope I'm talking about. So I have y2 minus y1 all over x2 minus x1. Again, I'm subtracting a negative number. I make sure that I have my brackets put in so that I don't make an error. I end up with 2 over 6, which simplifies to 1 over 3. Something that's going to be really critical later on when we come to our differentiation is the concept of rate of change, which you will have come across if you do physics or applied maths. So in rate of change is exactly the same concept as slope. It's still rise over run, but we just frame it slightly differently in our minds. So the rate of change is how quickly something is changing. And we always use the x-axis as our reference. So if we are looking at if we change x by a particular amount, how much do we change y? Well, if we change x by 3, we change y by 1. If we go across positive 3 on the x, we'll have risen by plus 1 on the y. So the rate of change here is a third because we go across 3 and up 1. That's our rate of change. That concept is going to be extremely important later on in the year when we're going to use it in quite an advanced setting. Now, just a quick reminder on the last two pieces on slope that we'll talk about today. Parallel is a name for, or parallel lines just means that we have slopes equal. If we see the word parallel, it means we have two equal slopes, and we need to know that without any further reminding. So in the back of our minds, if we see the word parallel, we know we're going to use the slope formula. That's guaranteed. Likewise with perpendicular, perpendicular refers to slope. So what we're going to do when we see the word perpendicular is you're either going to remember this formula. If we multiply our two slopes together, m1 and m2, we end up with them equaling -1. The other version of that, it means exactly the same thing but is done in English, is if I have the first slope, if I have m1, m2 is the negative reciprocal of m2. So if I start out with a slope of a third, like I did for AB, what is the perpendicular to that going to be? So the perpendicular slope to AB, it is going to be the negative reciprocal. So if I take the negative, it was positive, so if I take the negative, it's going to be negative. Reciprocal means flip the fraction upside down. So like you were dividing by a fraction, you'd have the reciprocal. So it was a third, I now flip that fraction upside down. If I started out with a slope of -2/5, the perpendicular slope would be the negative reciprocal, so the negative of negative is going to be a positive, and I flip the fraction upside down and it would be 5/2. So that is how my perpendicular lines are going to work. If I see the word perpendicular, it means I'm talking about slopes. If I see the word parallel, it means I'm talking about slopes. So I need to have that in my mind. They won't necessarily say slope. They'll ask you about parallel and perpendicular and expect you to know that we're talking about slopes. Now those are the skills that we need to practice from junior cycle for now.